Hi everyone, my name is Fernando Carvalho Ota. I'm a PhD candidate at the University of Luxembourg, and today I'm here to present you the ongoing work of creating a privacy-preserving data-centric super app. In this paper, we focus on providing an overview of the architecture we are planning to implement until the end of my PhD. But before showing this architecture, I would like to introduce the concept of the super app, which is basically an application usually mobile first. They offer services from different providers in a single platform. We name it member app, each additional application developed by these third-party service providers. In order to execute any transaction on users' data, the member app needs to be authorized, thus requiring an authentication server. The user interacts with an instance of the super app, which in turn interacts with the super app backend. This backend connects a database, storing information from the users and also from the member apps. The whole infrastructure should be auditable. At this point, we are assuming that there is an owner for this infrastructure, in the same way that Chinese WeChat has. But our research can show that maybe we can reach an infrastructure without any owner, or let's say a distributor or decentralized infrastructure. In fact, WeChat today is the largest super app deployed in the world. What we call member apps, they call mini apps, and they are offering several types of services from food ordering up to medical appointments. We can see here the screen of the super app. For example, McDonald's here is offering the food service. However, recent news have been reported that WeChat is censoring some content related to coronavirus. We have this news here from March 3rd. And in other words, there is a big privacy issue if the design of this infrastructure allows unrestricted access to users' data. In light of that, we are proposing an architecture with those four features. The first of all of them is called endpoint security. We aim to protect the backend so only real instances of the super app can hit the endpoint with security. Which means I cannot develop a script, for example, and go directly to hit the get or the post requests from the endpoint or the backend of the mobile application or the super app application in this case. All the design of the infrastructure considers that the user's data is private by design, and also the member apps can safely transfer data between each other while the user privacy is kept. Finally, we have this infrastructure should be able to be deployed in a cloud environment. We know that, for example, banks, they are willing to create these applications, these super app applications. There's a KPMG report showing that the banks should shift their infrastructure to the cloud, especially when we talk to the super app infrastructure. But with the architecture they are using nowadays, especially mainframes, they maybe not be they maybe not achieve this kind of goal of deploying in the cloud with a privacy preserving infrastructure. So having this cloud deployability feature should be a groundbreaker to the fintechs or the banking infrastructure in the world. We elected the Intel SGX as the root of trust. The Intel SGX is embedded in the Core i5 up to Xeon processor since 2016. An SGX can process data in a third-party processor without disclosing information even to the owner of in this case, the owner of the cloud, for example, is not going to be able to see the data that are being processed inside of their processors. The entity that does this kind of processing is called enclave, which is an abstraction of a separated part of the processor memory that is called by a host application. So this is should be the enclave and the host application. The developer can go and insert his code here, and any stakeholder can get an attestation report that the claimed code is run by a trusted enclave. To this end, we have the fused keys here. Actually, Intel SGX has two fused keys, one for doing this attestation report, and also another one for doing the sealing, what is called sealing, which is actually storing encrypted data outside of the enclave. And also the new releases of the libraries of SGX, for example, Open Enclave, they are supporting several types of cryptographic libraries. By using these SGX features, we propose the following architecture. The Super App Management System, the SAMS, what we call SAMS, is composed by three modules. The User Provisioning Module, which is a module to enroll users and create hash tables to mask the real identity of the users. And also we have the authentication module here, which is responsible for providing access tokens so the member apps can safely access user data when allowed. The privacy enhancing module that controls the permissions coming from the user of the super app, and help the member apps to create tunnels between them so they can communicate each other in a safe way. For example, using the triple diff-Hellman, there's the signal protocol, for example, and also to help aiding creating the session between the user of the super app instance and the enclave, so the communication between the super app and the member app is protected with that endpoint security that we were mentioning before. So every member app that wants to participate in the ecosystem should create its own set of host application and enclave. So the sessions from the super app instance are established with a trusted and attestable code. The SGX can also use those fused keys to cipher data outside of the enclave. So all the sensitive data they send in the story are going to be ciphered by the enclave. Also, if the backend needs to cipher data outside of the enclave, the backend of the member apps can also make use of the fused keys to cipher data outside of their enclaves. We ran a small experiment to show that masking function has a negligible time when executed in the enclave. I mean, a masking function is masking the original ID of the user. By concatenating this original ID with the member app public key and a salt, we can create a new anonymized user ID for each of the member apps. So each member app, they cannot trace because they know different IDs. And this function was tested in the Microsoft Azure Confidential Computing Platform with support to XGX and Open Enclave, with all the required cryptographic functions from the embed TLS library. The average 10 times of run showed that the whole encryption operation takes no more than 100 milliseconds, including creating the enclave and deciphering the data and the hash function. Finally, we conclude that this architecture has the following business outcomes. The SAMs can charge from the membership, the member apps can enrich data and sell each other, the users can be refunded by the sold data. We can also create token curated registers of users to be sold in a market, and SAMs can create tokenized data markets of users. In our future work, we plan to implement, test, and validate all the components. And we invite the research community to help if someone is interested. Thank you very much for your attention. I hope you guys enjoyed. And if you have any questions, please drop me a line into fernando.carvalho@uni.lu. Bye-bye.